It's Christmas project time! There's a box from PCBWay. Let's see what's inside. Opening it up, we have a free gift. It looks like it's a Christmas tree. Slightly ironic given what this project is all about, but let's have a look at this. It takes a coin cell battery, so let's power it up and see what it does. Stick the cell in and turn it on. That's pretty neat. We have a flashing Christmas tree. I like it. Well, let's have a look at my PCBs, which are also Christmas trees. These are amazingly well packed. So this took me ages to actually unwrap, but here we go. So if any of you are my friends, you'll know what you're getting for Christmas. You're going to get a little soldering kit. So they look pretty good. They come out really nicely. So we'll examine these and then let's get to the soldering station. So I've got these nice flashing LEDs that slowly blink and eventually they'll go out of sync and start flashing independently. So we need to get our resistors in, so we'll just insert them all and bend the legs a bit so they stay on. And I'm going to use some sticky tape just to hold them in place to make it easier to solder. I do find it quite hard when soldering with all of these LEDs and resistors to actually get the soldering iron in. So I'm soldering them all up. It's not the best soldering job, so I've fast forwarded it so you don't have to watch my terrible soldering. So we'll get through all of these. It's quite tedious, but now we're pretty much getting to the end and we're almost done. And the last one, so let's snip all the leads off. They do fly everywhere. It's pretty dangerous, so safety goggles or glasses are recommended. Or you can put your finger on the end and you get slightly stabbed when you're doing it. But either way, they will fly around the bench. So I'm powering mine from 5 volts and the square pin indicates the positive. So we have to put the long leg in the square hole. And I want to put the LEDs on this side of the board. So let's get all the LEDs inserted. This is another fairly tedious job, so we'll fast forward this bit so you don't have to watch it all. But let's get them in. And if you're very observant, you will see that I have missed an LED. So we'll solder these up. And then when I actually test it, I'll realise I'm missing one LED and we'll have to add that and solder it in. So what I do with LEDs normally is solder one leg and then you can see which ones are wonky or have come slightly out. And what you can do is you can just push from the other side and then heat up the one leg you've soldered and push the LED until it's flat. So there's a few that need that doing. So you melt the solder, push, and it pops into place. And then there's another one. It's quite difficult with all these legs sticking out not to stab yourself, so be careful. But we'll do these other ones that are sticking out, and then we'll be good to go once I've soldered in the missing LED. So let's have a look. So I've missed one solder joint there. We're doing the other side of the soldering now, so we'll complete our LEDs. And that's all the LEDs done, and here I'm adding the missing LED. So let's get that one soldered into place. And we're done. Now it's just a case of snipping off all the pins. There is a lot of snipping in this project. Now to power it, I'm going to use my bench power supply. So I'm just sticking a header pin in and then we'll solder that up and then connect it to my bench supply. So a quick bit of soldering, just making sure it's level and flat. So that's that soldered. And now we get our bench supply and connect it up. The positive and the negative. And there we go. So you can see that one of the LEDs is not flashing. Initially I thought this might be a broken LED, but it turns out I'd actually just forgotten to solder one of the pins. So we'll get that quickly fixed and then we have a fully working system. So that's our LEDs all soldered. Power it up And I really do like these self-flashing LEDs. They all start off in sync and then they slowly start to flash independently. So let's go and jump into KiCad and I'll walk you through the schematic and the design of this little Christmas project. So I've made a new project in KiCad and let's start placing our components. So we hit the place key, which is A, and it will load up the library. And now we want to have a resistor, so let's get one of our resistor symbols. So we'll just do a small resistor, so we'll place that. And now we also want an LED, so we'll bring up the component library again and we'll search for LEDs. So find our nice LED symbol, add that, and we'll rotate it so it connects onto the resistor. And now we just need ground and power. So for that we push the P key and we open up the power and search for ground and spell it correctly. So now we have our ground pin, so we put that on. We'll wire this up with the W button. And then we'll add in the power symbol, so P, and then search for 5 volts. There we go. Oops. So there's our power. KiCad can be occasionally quite bonkers. So let's wire up our 5 volts. And now we want quite a few LEDs and resistors, so I'll just duplicate this several times by dragging it with Shift and do that and repeat that until I have sufficient LEDs. I'm going to start off with 11 LEDs and see how that looks. So that's our LEDs all wired. And now we have a connector to actually connect up our 5 volt and ground power supply. So our next step, we can annotate our schematic, so that will put numbers instead of the question marks. So this will automatically do it, and we'll just sort our components by X position. So it should work from left to right and top to bottom, giving our components numbers. So we have D1, D2, D3. I'll also work out a nominal resistor value. So if we have 5 volts and a 3 volt drop across our diode, and I want about 10 milliamps, so 0.01. So that gives us a value of 200 for our resistor. So I'll just populate the value there on the resistor so that we can read the schematic and know what we're supposed to be doing. When I actually solder it up, I probably will just use the resistors I actually have on hand because I've got a big box of random resistors, so I'll see what I have. Now the next step is to assign footprints to our symbols. So we open up the assign footprints, it will load up the footprint library and also load up all of the things in our schematic. So we'll start off with the diodes, so we select all our diodes and then we filter by through-hole LEDs. Now my LEDs are going to be 3mm, so we find that in the list of footprints, and then I always have to remember to double click to actually assign the footprint. So once I remember that and I double click, we'll be able to move on to the next bit. So double click, and now our LEDs all have footprints. The next thing we'll do is the connector. So we'll filter by connectors, and I want a 2.54mm connector, and I need a 2-pin vertical. So we double click on that. And now we can do our resistors. So we select our resistors and then go over and filter by through-hole resistors. And then I'll select the appropriate footprint for our resistors and double click again. So that's all our footprints done. We can hit OK. And now it's time to move to our PCB. So we go and open the PCB tool. And then once we're in the PCB tool, we can update the PCB with the schematic. So that will load in all of our footprints into our PCB. So there we go. Now we have all our components. We'll just place them at a convenient place and zoom in and take a look. So now I'm going to import my board outline. So I've already exported an SVG from my drawing package and converted it to DXF. Go and locate that, and we need to set that to the right scale, so I know that 3 should work, and we're going to do it on the edge cut layer. So there's our nice Christmas tree board outline. We'll just place that, And I've also got some decorative lines that I want to put onto the silk layer, so we'll import that as well. I want these to be nice thick lines, so I will try changing the line thickness, but we also apply it to the bottom silk layer. So let's see what we get. Now obviously that's not quite what we want, so we'll try that again and we'll just go back to the normal thickness. I'm not sure what this thickness actually means because it does say millimeters, but that didn't seem like millimeters to me. So then we place our nice decorative lines and they'll appear on the bottom silk layer. So now's a good time to go into the 3D viewer and see how our board's going to look. So we open the 3D viewer up, we can see our components and we can also see our board. So if we rotate it round, we can see the bottom silk layer, so we can see our nice decorative lines. And one thing I noticed here is the components. I've chosen vertical resistors rather than horizontal resistors. So let's go back and fix that. So we go back to our schematic and we go and change the footprints for the resistors. So we open up the assigned footprints, select our resistors, and we want the horizontal version. So we'll filter by through-hole resistors, and we go and pick the horizontal version of these resistors. Apply those by double-clicking, and then hit OK. And now we can go back to our PCB, and we can hit the update button, and that will update from our schematic. And now our resistors should be the correct footprints. So now if we zoom in, we can see our resistors are actually the right orientation now. And if we double check on the 3D viewer, we can see that we have exactly what we want now. So going back to our PCB layout, we can now start moving the components into the position where we want them. So the first thing I'll do is turn off the rat's nest just to make it slightly easier to see what we're doing. We can now see all our components and we'll just move them into the positions where we want them. So the first thing I'll do is move the jumper down to the bottom of the tree and put it in the right position. And then I'll put the LEDs where I think it will be most elegantly arranged. So we'll move all of those into position and then we'll start moving the resistors across as well. So I'm trying to move the resistors to be close to the diodes that they correspond to. So I'm just tweaking the positions slightly, and I think we can add some more LEDs to this design. So we'll go back to the schematic and we'll just duplicate these last two LEDs and resistors so we have more to put on our nice Christmas tree. So we duplicate them. Once again, we can annotate the schematic by doing this, so automatically assign numbers. And now we can go back to the PCB and we can update our PCB, which will bring in our new components. So there's our two new resistors and diodes, so we'll just move these into the correct positions as well. So with all our components in the correct position, I'm just going to move all of the LEDs to the other side of the board, but I'm going to keep the label on this side of the board so that it doesn't interfere with our nice design for the silk screen. So we can jump into the 3D viewer to have a look at what our Christmas tree is going to look like. So let's bring up the 3D viewer, and it's looking pretty good on this side. So let's flip it over and see the other side, which also looks quite good. But if I look closely, I can see that I've left one of the labels on the wrong silk screen. So we can see a D and a number right there. So switching back to the schematic, we'll just go and fix that up. So we can zoom in and we can see our D13 there. So we'll just flip that to this side of the board and move it to somewhere convenient. So that's all our components done and our silk screen also finished. So I just need to go down and fill in the details for the jumper. So we'll just move this label to a nice position, rotate it, and then change it so it says 5 volts and 0 volts. And that will tell us where to connect our power and what power to connect. So we're now ready to do the wiring up. So I've switched back on the rat's nest And I've also turned off the silk layers so we can see what we're doing. So what I normally do is have a look at the rat's nest and just rotate the components so that it's not so overlapping. So in this case, I'm only going to rotate the resistors because I want to keep all the diodes in the same orientation. So now we can start wiring up. So we're going to start with the 5-volt line, and now we'll move on to the 0-volt line and fill in all the wires for that. So now all the wires are done, we're ready to export our Gerber files. So I have run a DRC first, just to make sure everything is connected, and now we just plot the Gerbers, and then we also generate the drill files. So generate drill file, and what we'll do is we'll zip all these files up, and then use an online Gerber viewer just to check that it looks sensible. So here's our file in the Gerber viewer. We can view all of the details and just make sure that it does look sensible and we haven't forgotten anything. So I'm pretty happy with this. So what I'll do is I'll now go on to PCBWay and we'll order the PCB. So we can use the PCB instant quote, and we just need to upload our Gerber file. So with our Gerber file uploaded, it auto detects it's a 2-layer board and it detects the size. So I'm going to use a white solder resist mask. So when we pick the white mask, it will automatically default to a black silk screen. And then we can just check out, and then our order gets produced and gets shipped to us. So there we go. That's our PCB Christmas project done. It's pretty nice, and I'm pretty pleased with the free gift I got from PCBWay. So I'll be doing some more videos before Christmas, so there'll be another one coming soon. But if I don't see you before then, have a great Christmas, and I'll see you in the new year.